ఇప్పుడే పెట్టమంటారా తర్వాత చేయమంటారా?
మీరు తర్వాత చేయండి సార్, మీకు ఎప్పుడు.
ఓకే అండి, ఓకే, సరే,
థ్యాంక్ యూ.
ఓకే. హలో, గుడ్ ఈవినింగ్ ఆల్. This is Balakishan. My name is B. Balakishan, Associate Professor, Jyotishpati Institute of Technology and Science, right? Okay, today is the first class of data warehousing and data mining. Yeah, is it okay? My voice is audible?
Yes, sir.
Hello, is my voice audible? Any technical problem is there? Okay,
No,
yeah.
sir, everything okay.
Yeah. So what is the idea of data warehousing and data mining nowadays at present situation? So, okay, I will give one real example. Okay, at present, everywhere we are using computer systems. Okay, when it comes to retail market or banking or whatever it may be, where everywhere, right? Everywhere we are using databases, large amounts of databases, and everywhere we are storing the transactions, right? Okay, for a best example is when it comes to banking system. Okay, consider the banking system, right? For 24 hours, okay, consider for 24 hours in our country, India, millions of transactions are happening. Millions of transactions are executed by the customer. Okay, so what the bank people is do, all these transactions will be stored every day. Okay, per day 1 million transaction. For example, consider 10 lakh transactions. For 2 days, 22 million transactions. And for 3 days, it is 3 million transactions. Okay, and the banking system, they used to store large amounts of data. Okay, when it comes to per day, weekly, and 10 days, 15 days, 1 month, 6 months period, 1 year period, for 2 years period, 5 years period, 10-year periods, right? Okay, large amounts of data is there. Then the next question is, okay, we are already storing large amount of data. So what we can do with this large amounts of data? The next question comes is that, okay, what we can do with the large amounts of data, right? Okay, so when we see the slide, okay, what it says, the explosive growth of data from terabytes of data to the petabytes of data. Okay, so it comes under data collection and data availability, right? And the best example, so what this banking people will do, okay, they will study the behavior of the customer finally. Okay, every day for 24 hours. Okay, they, for example, they are storing 1 million transactions. For 2 days, 2 million transactions. For 3 days, 3 million. For 10 days, 15 days, 1 month, or 6 months, or 1 year, 2 years, 5 years, 10 years. It is large, very, very big amount of data. Okay, where all this data is stored, there you get the concept of data warehouses. Data warehouses, large amounts of data can be stored. Okay, after storing, what we need to do? Okay, what to do with this large amounts of data? Then the next question comes is that, okay, what to do with this large amount of data? Then they start mining specific information, mining patterns, mining knowledge, you can say that, right? Very important information. Okay, finally what we can say is that in simple language, okay, out of these millions of transactions, banking transactions, okay, the banking people, the banking system, they mine the information. Okay, what we can say is that, okay, they study the behavior of the customer. They study the behavior of the customer. They study the behavior of the customer. Then what to do with this behavior of the customer? Okay, that means they will target the customer. So they will attract the customer. Okay, so whom to sanction the loan, for example, whom to sanction the loan, whom to sanction the credit card. Okay, all these based on this data warehouses and data mining information only, right? So for this data collection, data availability, we use the automated data collection tools, database systems, web, computerized society, right? And major source of abundant data, like just now we said, okay, one is the business, the second one is science, the third one is that society and everyone. So when it comes to business, it is web. When we talk about web, large amounts of web pages are there. Billions of web pages are there, not one and two or 10 or millions of web pages. Every day, every minute, millions of web pages will be added, deleted, updated, modified. Okay, whatever the data is there, we can say mostly dynamic information when it comes to web. Billions of web pages are available. Okay. And e-commerce, when it comes to business, e-commerce and transactions and stocks are there. Stock, okay. The last example is that stock market. When we talk about stock market, every day, okay, in India, for example, we have the two stock markets are there, National Stock Exchange and Bombay Stock Exchange. There also millions of transactions will happen. Okay, buying the shares and selling the shares, right? So all these are recorded. So what to do with this recorded information? Finally, we can study, we can understand the behavior of the customer. So finally, what we can say is that when we mine the specific information, okay, when we perform the mining, okay, we can get the specific information, particular information, or we can get the knowledge finally. So with that knowledge, okay, they'll target the customer most of the time. Okay. And when it comes to science example, we have the remote sensing, bioinformatics nowadays, and the scientific simulations are there. So what is the idea for remote sensing? There also we use the large amounts of data. What type of data it is? Okay. For example, ISRO is there. We have the satellite Indian Space Research Organization. Okay, they deployed so many satellites, right? And what is the role of those satellites? They'll take the pictures. Okay, when it comes to remote sensing, they'll take the pictures of the Earth. Okay, and those satellites will send thousands and thousands of pictures every day. So finally, what to do with that thousands and thousands of pictures? Okay, that means, so what is the use of remote sensing? Okay, that means what type of material, which material is available, where we can find the petrol, where we can find the resources such as petroleum products, petrol or coal or gold or whatever it may be, silver or copper or whatever it may be. Okay, through these pictures, okay, remote sensing satellites send pictures. Okay, through these pictures, we can understand. Okay, we cannot study as a human being, as an engineer, we cannot read each and every individual picture. Okay, we will provide all those images to the algorithm or program. Okay, and then finally the algorithm will scan each and every picture, and they'll find some specific information. That specific information we can say mining process, right? That means where we can find the gold, where we can find where the gold is available, where is the possibility of availability of gold, silver, copper, or petrol, or whatever it may be, coal, all these things, right? All these are real-time examples: remote sensing, bioinformatics, scientific simulation. And the third category is the society and everyone. So nowadays we are using WhatsApp is there, Facebook is there, Instagram is there, YouTube is there. Okay, every day, every minute, every second, thousands and thousands of pages are uploaded, right? Thousands and thousands of pages are uploaded. So what we are doing, the best example is, okay, when we see a particular, when we are interested towards a particular site or web page, or for example, some information is there, then the what comes is that, okay, the same type of content will be provided by the Instagram or whatever it may be, those social networking sites. Okay, so on what basis they are doing this one? Okay, they are mining what the customer is searching. Okay, what type of information is searched by the customer. Okay, what type of content is needed by the customer. All these comes under the mining process, right? News, society, and everyone, news is there, digital camera is there, YouTube is there. Okay, when we see a particular video, the same type of video, okay, are continuously uploaded, continuously visible to us, right? This is also the example of data mining, right? So next one is, we are drowning in data but starving for knowledge. So just look at this statement. We are drowning in data but starving for knowledge. What do you mean by that very big statement? Okay, just now I said We are drowning data means, okay, we have large amounts of data is there, terabytes and terabytes, petabytes of data is there. Banking system storing, YouTube, they are storing millions and millions of videos, Instagram, chats, all those things, websites, www, billions of web pages are there. Okay, that means we are drowning in the data. Data is available. Then the next question comes is, so what to do with this data? How the data is useful? So this statement is, but starving for knowledge. Okay, we want knowledge. We don't want raw data. Okay, we don't want thousands of pages. We don't want thousands of websites. Okay, we extract. We want so a particular information, specific information. Okay, that is called as a that where it strikes the data mining concept strikes mining specific information. Right. Okay, the best example is, for example, gold mining. When we talk about gold mining, so gold is purely not available, raw material is available, so much of cleaning process must be done. Okay, when we extract a pure gold, so much of scientific procedure must be followed. Okay, raw material is available. From that raw material, okay, we must extract pure gold. It takes lot of time, lot of scientific procedures, technical procedures, then only finally we can extract the gold. In the same way, we are drowning in data. Data is available, but starving for knowledge means knowledge is not available. Specific information, important information, particular information is not available. Okay, there comes the data mining process. So that is these two are related: data warehousing and data mining. When we want to store large amounts of data, there we take the help of data warehouses. There we can store terabytes of information, petabytes of information. Okay. Then after storing that one, we need to retrieve. There comes the concept of data mining. Mining means retrieving specific information, particular information, important information. Finally, what we can say, retrieving knowledge, right, from that data warehouses. So the next statement is necessity is mother of invention. Okay, data mining, automated analysis of massive data sets. Right. So when we see the evolution of sciences, we all know that one. Okay, from engineering first year onwards, not only engineering, when we talk about science, okay, all these are known to us. That is 1600 to 1950s, empirical science, theoretical science, computational science. Right? In computational science, we have the computational ecology, physics, language, linguistics. Linguistics is related to or nothing but the language, right? Computational science, traditional means simulation. And there comes the 1990s to till date, 1990s to now. That is the concept of data science. Nowadays, okay, everywhere we are hearing data science, data analytics, okay, business analytics, business intelligence, all these are interrelated. Data mining, all these are interrelated, right? And when we see the database evolution, okay, before data mining concept, we have the databases concepts, right? So every technology, okay, there are some positives and negatives, advantages and disadvantages. So in databases, generally we use the terminology relational databases. Okay, whatever the data is, there will store in rows and columns. Okay, and we try to find the relations. Nothing more than that. Okay, we cannot extract. We cannot say that. Okay, we can extract the knowledge from the databases. That is the drawback of databases, right? So when we talk about 1960s, that is data collection, data creation, IMS systems and network DBMS are there. Next one, we have the 1970s relational data models, relational databases. At present, we are using all these things. Okay. Some famous databases, we all know that one, Oracle database and MySQL. In our laboratories, we use the MySQL databases, PostgreSQL databases, DB, from IBM companies, DB also, right? Till date, we are using this relational data models of relational databases management system. 1970s onwards, 1980s, RDBMS, 1990s, there comes the data mining, right? In 1990s, it started coining data mining, data warehousing, and multimedia databases and web databases. These are very important. When we talk about data mining, we have the data mining, data warehousing, multimedia databases, and web databases. Okay, we all know that one data warehousing. So the best example for multimedia database is that the YouTube is the best example, right? Every minute, every second, hundreds and thousands of videos are uploaded, okay, uploaded or downloaded, okay. So how to maintain, how to store all these things, and how to index means, okay, properly store those videos, okay. Whenever the user, the customer requires a particular video, that must be provided to the end user, right? That must be provided to the end user or the customer within fraction of seconds. So how we can do that one? Okay, we need to mine, we need to index those proper those multimedia videos, all those things. And next we have the web databases is there. We all know that one, www, World Wide Web, and there where not millions, billions of web pages are available. So what to do this, what to do with this billions of web pages? We cannot do all these things. Okay, when we search something, we'll get thousands of web pages. From that thousands of web pages, okay, we need to extract from our side. Okay, the Google is not providing the specific information, just it will provide the websites. From those websites we need to extract some information from website 1, some information from website 2, some information from website 3, or web page 4, or web page 5, web page website 5, 6, like that. Okay, so at present we are the most famous one is that chat gpt is there. Everyone knows chat gpt. That is quite opposite of Google search engine system, right? In Google search engine system, what we are doing, just we are providing the keyword, search keyword. Based on that search keyword, okay, the Google is already has indexed those millions and millions of web pages. Based on the search keyword, okay, the Google search engine will provide the websites in a particular order, what we call ranking, where most relevant information will be available, where the next relevant information is available in website 2, website 3, website 4, website 5. So what is the problem with this Google search engine system? The user has to open all those websites, okay, extract the information, required information from website 1, website 2, website 3, nth website. Okay, that is our duty, the customer or the end user's duty to extract the information. The quite opposite to this one, at present we are using, we have the technology available, most advanced technology available, that is Chat GPT, Chat GPT, DeepSeek, or Gemini from the Google. Okay, all these are available. So what is the use of all these things? Just you ask a question. Okay, when it comes to Chat GPT or Gemini or whatever it may be, DeepSeek or whatever it may be. Okay, all these. Okay, just you ask a question, it will give the answer. Then what is the use of Google now? There is no use of Google at present, right? So whatever we ask, that answer is provided by the, most of the time, perfect answer is provided by the Chat GPT, all those systems, right? Advanced version, we can say advanced versions of data mining, warehousing, multimedia databases, web databases also in near future also. And when it comes to 2000 onwards, 2000, okay, what it says, stream data management and data mining, its applications, web technology, all those things, stream data management and mining. For example, streaming means live streaming is there, right? Live streaming, for example, police control room is there. Okay, in every city, the police department, they used to maintain closed circuit cameras, CCTV cameras at different locations, different places. All these are monitored in real time. Okay, on in real time monitoring is there, and they used to capture. Nowadays, those intelligent softwares are there. They can extract the specific person, they can understand, they can capture some faces or all those things, they can recognize the faces. Okay, and that information is provided to the police department. They will take care of the thieves or robbery or whatever it may be. Okay, some crime record is there, those people will be captured. Okay, this is also one example of stream data management. Stream means live stream. Then we move to the, what is data mining, right? So as per the definition, data mining, we can say knowledge discovery from the data, raw data. Data means raw data, large amounts of data. That is not useful. Okay, we can say that mostly, we can generally, in general, we can say that, okay, I used to maintain large amounts of data. I have lot of information. I have thousands of files are there. I have thousands of PDF documents are there. I have thousands of HTML files are there. Then what to do with this all these thousands of files? We don't want all these things. We want knowledge. We want to extract specific knowledge. Okay. So data mining, we can say that knowledge discovery from the data. So extraction of interesting, that is non-trivial, implicit, previously unknown, potentially useful. Previously unknown. Previously that information is not there. Okay. Generally, when we talk about knowledge means, for example, in our textbooks also, at the end of each and every chapter, we have the summaries there. Okay, every author in textbook, in a standard textbooks, they used to provide the summary. Okay, that is also the best example for knowledge also. Okay, the chapter may contains 40 pages or 50 pages or 100 pages. And finally, we have the summary. The summary is provided within a single page, some points, 10 points or 15 points or 20 or 30 points. We can say that those 15, 20, 30 points are very important. We can say that is a knowledge. With those summary, we can understand all those the chapter concept that is 40 pages or 100 pages, right? That is also the best example. Previously unknown. Okay, previously unknown. Why we are saying previously unknown? If it is known to us, we cannot say that knowledge. Okay, we want more specific information, particular information, right? That's why we have used the word previously unknown. And potentially it must be useful. Okay, whatever we extract, that must be very, very useful. Patterns. Here we say that patterns are knowledge from huge amounts of data. So what is the idea of pattern? Can anyone say, give the answer? Patterns. Patterns means some sequences there, some repeated things. For example, okay, we have problem is there. First time we have to face some problems. Okay, we try to find a solution. Again, the second time also we have the same type of problem. Okay, for that, to find a solution for the second problem, we cannot go from the scratch, because the problem is belongs to the same previous problem, same category, same domain. That means what are the solution we have found for the problem one, we use the same solution for the problem two also. The pattern means the same type of same problem. The problem is repeated, the solution is known to us, just apply the solution. Right? Or knowledge from huge amounts of data. Yes. Someone gave the answer, something like that. Okay. And alternative names. What is alternative names? Okay. For alternative names for the data mining, we can say that knowledge discovery in databases. We can say the other name for data mining is that knowledge discovery or knowledge mining in databases. That is KDD. Okay, that is nothing but knowledge extraction, data or pattern analysis, data archaeology, and data dredging, information harvesting, business intelligence. All these words are related together. We can say that's interrelated, right? So is everything data mining? The next question is everything data mining? Can we say whatever we do? Okay, that is simple search and query processing. That is deductive system or expert system. Yeah. Okay, we'll start this. The first procedure of now, what is the KDD process? KDD or knowledge mining or data mining, all are same. Don't confuse with this for terminology. Okay, in place of data mining, we can use the knowledge discovery in databases, KDD process. So what is this KDD process? Okay, this is the base diagram. We can say that this is the basic process of knowledge mining, how the knowledge is processed, right? Okay, the first one, we have the data warehouses. The first point is that starting data warehouses where large amounts of data is available. Yeah, is someone is talking with a microphone? Is my voice audible? Any disturbance is there? Yeah. Okay, in the beginning we have the data warehouses, right? First starting point. So from this data warehouses, what we can do, okay, that is internal process, circular process, okay, we can say data cleaning and data integration. Data cleaning means, okay, we use, hello, is someone talking? Some disturbance is there. Can I can I talk to Rajesh, MCA? Hello, is someone mic is on? I think some students mic is on. Can you switch off that mic? Hello. Yeah. Okay, I'll continue. We have the data warehouses, okay, where the large amounts of data is stored. This is the main diagram. Please remember, right? Okay, all of you. Data mining process, what the data mining process is, what the knowledge discovery in data mining process is, right? We have the data warehouses where large amounts of information is stored. From that one, okay, we need to perform the data cleaning. So what do you mean by data cleaning? Data cleaning process means, right? Okay, we used to collect the different types of data from different sources. We used to collect. What is the idea of data cleaning? Before processing something, we must clean the data. So why we need to clean the data? Because we used to gather the different types of information from different places, different people, different resources, right? For example, we can collect, okay, a normal flat file or a database from the databases, from the web pages or from the websites or from other systems or different types of systems, okay? So we need to perform the data cleaning process. Next one, from data warehouses to task relevant data is there. Task relevant data, data mining and pattern evaluation. Finally, we can say knowledge. Okay, we have retrieved the knowledge. Okay, all these, it is a continuous process, repetitive process. Okay, not a one-time process, right? Selection and data integration. So what is the idea of data integration? We need to integrate different data resources. Integration, what is the idea of data integration? We need to integrate different resources, different data resources from different places, right? It can be flat files, it can be relational database management system, it can be from the World Wide Web, or it can be from the banking server, or whatever it may be. Okay, different resources. We need to integrate all those things, right? That is the idea of data integration. And you can say selection. So what is the idea of selection? Selection means, okay, based on the problem, okay, we have the different types of problem. Based on the problem, we need to select a particular data. Based on that specific data, we need to perform the data task relevant data, and we need to perform the data mining. Then patterns must be evaluated. So whatever we have retrieved, okay, from the mining process, all those must be evaluated. Right? Patterns must be evaluated. Evaluated means whether whatever we have retrieved, that is as per the standard or not, whether that those information, that those patterns are very important content, whether it contains very important information or not, all these things, right? Pattern evaluated. After pattern evaluation, finally we'll extract the knowledge. Okay, this is the main diagram, base diagram of data mining. That is right. Okay, data cleaning to data warehouse to, okay, task relevant data, data mining, we need to perform the data mining process, and pattern evaluation, finally we'll extract the knowledge. Okay, internally we have the selection process, data integration process, and data cleaning process. So okay, we will consider one example, a web mining framework. Web mining is nothing but World Wide Web. Consider the World Wide Web. Web mining usually involves, okay, that is data cleaning, data integration from multiple sources, warehouse the data, data cube construction, So what is the idea of data cube construction? Okay, the data can be in two-dimensional format or three-dimensional format also, right? That's why we have said data cube construction. Then data selection for data mining and data mining. Then finally, presentation of mining results. And finally, the patterns, extracting patterns and knowledge to be used are stored into knowledge base, right? So when we talk about data mining process in business intelligence, just now I said, okay, nowadays these buzzwords are there: business intelligence, data analytics. Okay, BI used to say business intelligence, data analytics, data mining process in artificial intelligence. Okay, machine learning. All these are related together, interrelated together. So finally, when we see this data mining process in business intelligence, that is the first one is data source. From that one, data pre-processing and integration and data warehouses. Then exploration, data exploration. In this, we have statistical summary, querying and reporting. Then next step is data mining, information discovery, then presentation. Whatever we have discovered, that was presented. Okay, so that we can easily understand. The presentation can be in a summary format or graphical format, graphs or charts or whatever it may be, right? Visualization techniques, right? And finally, decision making comes. Okay, whatever the available information is there. Okay, that is end user. End user will perform the decision making process. The business analyst will prepare the data presentation, whereas the data analyst perform the data mining process. And DBA, database administrator. What is this DBA? Database administrator, right? They'll perform all these things: data pre-processing, data exploration, all those things, right? So this graph says, okay, in upward direction, increasing potential to support the business decisions. Yes, because we are extracting knowledge, we are extracting specific pattern, all those things, right? So when we see the data sources, okay, we can collect the information, data from paper, files, flat files, web documents, scientific experiments, database systems, all those things. So all these are performed by the DBA, data pre-processing, data exploration, till data exploration, database administrator. Then the data mining process. Okay, then the data mining process is performed by the data analyst. Here we see when we see the diagram, and the data presentation, that is visualization techniques. It can be graphs, bars, charts, all those things, right? Okay, visualization techniques, so that we can easily understand, so that we can easily extract the specific information, particular information, very important information, through visualization techniques. Okay, that is performed by the business analyst. And finally, the end user. End user will take the decision making process. So who will be the end users? That is generally we can say chief executive officer, CEO, chief financial officers, chief information officers, the managers at the highest level. Okay, they will perform the decision making process, right? And when we see the example, that is what is different mining versus data exploration. Okay, when we see mining versus data exploration, that is business intelligence view. There, when we talk about business intelligence, we have the concept of data warehouses, data cubes, reporting, but not much mining. Mining is not performed most of the time, right? Just 10% or 20%. And here the concept of business objects and data mining tools, supply chain example, that is tools, data presentation and exploration, right? All these are the examples, real-time examples. And when we see the KDD, knowledge discovery in databases, the other name for data mining is that, remember, all of you remember, the other name for data mining is that, are interchangeable, we can use the word KDD, knowledge discovery in databases. Okay, a typical view from ML. Nowadays it is famous, right? ML means machine learning and statistics concepts, right? So when we see this diagram from the point of view, statistics point of view, we have the input data is there. Input data, then what we'll do, data pre-processing. Pre-processing means what the name is, pre-processing. That means unnecessary data, removing unnecessary data, removing useless data, all those comes under the pre-processing. Unavailable data is there, some data is missing is there, then what to do with that missing data, all this comes under pre-processing. Then we'll perform the data mining on pre-processed information, then post-processing. Data pre-processing, then perform the data mining, then post-processing, then finally we'll retrieve the pattern, information or knowledge. So what we'll do it pre-processing, under this pre-processing we have data integration, normalization, feature selection and dimension reduction, right? Data integration, integrating the data from different resources at different locations, different types of file formats, all those things. Normalization, so that we can easily understand. Feature selection, what is feature selection? Okay, when we talk about databases, we have so many attributes, or we can say that columns, right? And for a particular problem, we don't use all those columns, we use only some of them. Okay, some attributes are very important, okay, for a particular problem with respect to some particular problem. So that's why we call it as feature selection. Not all the features will be selected, only some features will be selected based on the problem. And dimension reduction, okay, the data can be in three-dimensional data, two-dimensional data is there. Okay, to understand for a particular problem, okay, we don't need three-dimensional data, we need, for example, two-dimensional data, something like that. That means in that case dimension must be reduced. And when it comes to data mining process, we have the pattern discovery, association and correlation, classification, clustering and outlier analysis. All these are the data mining functionalities, okay, general or standard functionalities when it comes to data mining. Okay, when it comes to, remember, data pre-processing, we have the data integration, normalization, feature selection, dimension reduction. And when it comes to data mining, we have, these are the functionalities: pattern discovery, association, correlation, classification, clustering and outlier analysis. Okay, all these topics are, we have the chapters, individual chapters we will study in detail. Right? And when it comes to post processing, we have pattern evaluation, pattern selection, interpretation and finally visualization. Okay, we'll study in detail all this. Okay, the best example, okay, when we talk about data mining system, knowledge discovery in databases, we have medical data mining is there. Nowadays medical data mining is very famous, right? Every day, okay, every hospital management, they used to store the customers, the patients records, patients information data, right? So what type of problems they are facing, okay, the test results of each and every patient, okay, everything is stored. When that particular patient is visited, with what type of problems, what type of symptoms are there, all this, okay, will be stored. Based on that information, finally the doctor can easily predict, okay, with the, okay, this particular patient is suffering from this particular problem, okay, right? Medical data mining, the best example. Healthcare medical data mining, often adopted as such a view in statistics and machine learning. Pre-processing of data, including feature extraction and dimension reduction, just now we discussed, classification and clustering, and post-processing for presentation. Finally, the presentation. Okay, whatever the knowledge we must extract, that must be presented. Okay, so that we can easily understand, so that the end user, here, when it comes to data mining or knowledge discovery, the end user will be, remember, the highest level of people, the managers, chief executive officer, chief financial officers, chief information officers, okay, data engineers at the highest level. And when we talk about multi-dimensional view of data, data to be mined, that is from database data. It can be from extended relational object-oriented databases, heterogeneous databases, data warehouses, transactional data. Okay, when it comes to transactional data, the best example is that banking system, insurance system or banking system, there where per day 20 millions of transactions will be executed by the customer. Stream, spatial, temporal, time series, sequence. So all these are the different areas where we can apply the data mining concept, right? knowledge to be mined. That is data mining functions. Okay, these are the data mining functionalities. Knowledge to be mined. What type of knowledge to be mined? Okay, the knowledge can be not a single one. We can have different types of knowledge. We can say that characterization, discrimination, association, classification. All these are the different types of knowledges. Remember that one. Or we can say that data mining functionalities. Characterization, discrimination, association, classification, clustering, trend or deviation, and finally the outlier analysis. Okay, we'll study in the next upcoming chapters. And what type of techniques we utilize, okay, for this data intensive, or we can say that data warehouses. When it comes to data warehouses, online analytical processing, OLAP, we used to say that OLAP is related to data warehouses. Okay, that is online analytical processing, machine learning, statistics, pattern recognition, visualization, high performance applications adapted. Next, data mining on what kinds of data? Okay, we see when we see database oriented data sets and applications, that is relational databases, data warehouses, transactional databases. And when it comes to advanced data sets and advanced applications, for that, the input is from the data streams, sensor data, time series data, sensor data. Okay, so nowadays these are famous. Nowadays we hear about IoT, right? Internet of Things. Internet of Things, okay. Internet of Things means whatever the electronic gadgets we have as a okay, whatever the electronic devices we have, all those devices are connected. For example, in our home also, our AC is connected, geyser is connected, all electronic gadgets are connected through mobile phone or through internet. Okay, wherever you are. Okay, you are at office. Okay, and you you are coming to the home, and your geyser will be on by just clicking some buttons, okay, in your application or in your mobile phone. Okay, within 5 minutes or 10 minutes, that particular device will be activated, and the device will provide the services, right? Sensor data. Or the other example is that in medical field also, for a patient, okay, the doctors they use different types of sensors, right? All this information will be stored. Based on that information, the doctor will take the decision, right? What to do next, what to prescribe for that particular customer, for that particular patient. Time series data, temporal data, sequence data, structured data, graphs, social networks. We all know that one, Facebook, Instagrams, all these things. Multi-link data, object relational databases, multimedia databases, text databases, and the World Wide Web. Wait a moment. Okay. First, okay, we'll start with the data mining functionalities. The first one is the generalization. Data mining functionalities, that is generalization. What this word says, generalized. So whenever we have a lot of information, lot of knowledge, right? In general, we use the word, okay, in general, I want to say something in general. That means generalized one. Okay. For example, when we talk about a particular class, okay, when we talk about the percentage of a class, so we can talk specifically also. That means, okay, 20 students got more than 70%, or for example, 20 students got more than 60% or something, 20 students got, 10 students got more than 80%. So this is specific information. Okay, how we can generalize this particular statement? Okay, when we perform the average of the percentage of all students, right? Okay, in general, okay, when we calculate the average of all the students percentages, we can say that for this particular class, the average is the 65%. Then we can say that it is a generalized statement, right? In general, we can say that overall, right? Information integration, data warehouse construction, that is same data cleaning, transformation. Transformation is nothing but, okay, from one form to another form, so that we can understand based on the problem, based on the algorithm. Okay, for example, best example is that, okay, when we write a program, the program is whatever the program we write, that is a high level programming language. We'll take the help of high level programming language. such as C or C++ or Java or Python, whatever. All this comes under high level, but the machine understands only the low level language, machine language. Okay, that must be that high level language must be transformed from high level to low level. In the same way, the information must be transformed based on the problem, based on the category of the problem. Okay, so that we can perform the mining process, transformation, integration, and multi-dimensional data model. And just now said data cube technology, that is scalable methods for computing, materializing multi-dimensional aggregates, OLAP, online analytical processing, and multi-dimensional concept description, characterization, and discrimination. So what is that? What do you mean by characterization and discrimination? Characterization, character or characteristic. Okay, whatever we talk about, okay, something, okay, regarding a particular issue, what are the characteristics of that particular device or work or job or task in the same way, right? And discrimination means comparison. Generalize or summary or contrast, compare the data characteristics. That is, for example, dry versus wet region. Okay, when we compare a region, we can say that, okay, which is the driest area, which is the wettest area. Okay, comparison, right? Contrasting. The next one is that, okay, all these are the definition level only. Data mining function, that is association and correlation analysis. So what do you mean by association? What the name says, association. Association means we must have two elements, two components. So what is the association between any two person? How those two people are related together, how those two products are related together, how those two components are associated together. Okay, what type of relationship is there between those two components or two persons or two elements, all those things, right? Association and correlated, how those two elements, two components are correlated together, what type of dependency is there, right? Frequent pattern, this name says, okay, under this association and correlation analysis, we the most famous used word is that frequent patterns, frequently occurring patterns, frequent item set. So what items are frequently purchased together in your Walmart, for example? So what is the best example for frequent pattern? Okay, when we visit the Reliance or DMart, whatever it may be, some products are kept together side by side. Why? Because, okay, the best example is that when we buy a milk product, okay, milk product is there, bread is there, jam is there, all these are associated together. When we keep all these products side by side, the customer will definitely buy those products. If we keep those products apart at different places, the customer may forget that one. So this is the best example, frequently purchased. Best example is that when we buy a bread, okay, we need cheese, or for example we need jam or some other, all those things. Okay, that means those two products or three products must be kept together at nearer to each other, frequently purchased together. Okay, and association, correlation versus causality, causality, not casuality, causality. So we can say that a typical association rule, okay, this is just now we discussed. Okay, a diaper and beer is there. For this, we have the support value. The two measurements are there when it comes to association. One is the support value and the confidence value, right? So when we buy a diaper, okay, definitely it leads to beer. Is this true? It says that 0.5% and 75%, right? So from this statement, we can say when we buy a diaper, whether this buying diaper leads to buying the beer. Okay, so for this statement, these are the statistical values. Support value is 0.5% and confidence value is 75%. From this, we can say are strongly associated items also strongly correlated. So how to mine such patterns rules efficiently in large data sets? Okay, how to use such patterns for classification, clustering, and other application. We'll see in detail. Okay, these are the definition level, starting point level only. And the next one is classification. Okay, with this, just I will stop the first class. Today is the first class, right? Okay, data mining functions, that is classification. Third functionality is classification. Just remember this one. The first functionality is the generalization. Data mining functionality, first one is generalization, second one is association and correlation, and the third one is the classification. Okay, classification and label prediction. So we need to classify whatever the available information is there, it must be classified. The best, for example, when it comes to percentage of students, okay, those are classified. Okay, we can say that less than or equal to 50% and greater than 50% and less than 60%. That is second category. Next one, greater than or equal to less than or equal to okay 60% and above 60% and less than 70%, that is 60 to 69%, one category, one classification. Then 70% to 79%, then 80% to 89%, right? Classification and label prediction. Okay, I will stop within 5 minutes. Okay, just we'll see the definition. Classification and label prediction. That is nothing but construct the models or functions based on some training example. Describe and distinguish classes, concepts for future prediction. Okay. Classify countries based on climate. Okay. For example, we want to classify the countries. Okay. On what basis we can classify the countries? Based on the climate, for example. The hot weather is there, cold weather is there. Okay. Very less temperature is there, very high temperature is there. Or we can say that classifying the cars. Okay. We can also classify the cars also. Okay, the cars runs with petrol, the cars runs with diesel, the cars runs with electric cars, we can say that, or the cars runs with we can say two in one, or we can say hybrid cars, right? That is classification. Classifying the cars, classifying the countries based on the climate, classifying cars based on what type of whether they use the petrol or whether they use the diesel or whether they use the compressed CNG gas or whether the LPG gas or whether they use the electric cars, right? Classification. Predict some unknown class labels. Typical methods are under this for classification. We have this decision trees, Navy Bayesian method, classification, support vector machine, neural networks, rule-based classification, pattern-based classification. And typical applications of classification are, okay, all these are real-time examples. We all know that one. Credit card fraud detection. Credit card fraud detection also comes under the classification. And direct to marketing, classifying stars, diseases, classifying web pages, right? Yeah, for today's class, we'll stop here, the first class, right? Is anyone is available? Can anyone respond?
Yes, sir.
Yes? Okay. Any queries or questions are there? Anything you want? Okay, for today's class, okay, first class it is. Okay, I'll stop here. Okay, in the next class, we will discuss in detail all the topics, all these, whatever we have discussed till now, all those are the basics, the definition level, the starting point, introductory level, right? Right. We'll discuss in detail in later classes, right? If you have any queries, can anyone? Some Devi, Sarika, some Vasavi, some people are there. Participants, it is around Sai Parimala, Sri, Sarika.
Up to now, no queries, sir.
Yeah, tell me.
Up to now, no queries, sir.
After?
No queries, sir.
No queries, sir? Yeah, okay, no problem. Right, okay. Okay, in the next class, we'll discuss in detail all the topics, right? Okay. If you have queries, you can post messages in Zoom, right? Okay. Shall I stop? Is Rajesh is available? Can I stop the this meeting class? Is Rajesh available? Rajesh from MCA, I think he gave some number. Sai Kumar. Yeah, thank you. Okay, some charts are there. Sir, the voice sloga vastundi. Okay, okay. In the next class, I will clear my voice. Any technical problem is there, right? Yeah, thank you all. Thank you very much. Okay, we'll meet in the next class. Thank you. Yeah, I'm closing the session, right? Thank you.